All right, so now I'm just going to work a couple more examples, but we're going to look at if the period, basically period just means the cycle, is going to take longer or less time to complete. And so you'll once we do a couple examples, it'll make a little bit more sense. But how do I know whether the cycle has changed? So far what we've seen is the cycle is basically, and it still is going to be related to the unit circle starting from 0 to pi over 2, pi 3, pi over 2, and then back to 2 pi. Except that it might take more or less to get to each stopping point, okay, to get to those points, okay? And so the period is just 2 pi divided by b, in which b is going to be the coefficient of the variable x right there. So b is just that coefficient right there. And so on all the previous examples, it was just an understood 1. Okay, so I think the best thing for us to do is probably just jump in and do one of these. I do have a tip on how to create the table, and we'll talk about that when we start making the table in just a second. First, let's go ahead and graph the parent function, because once again, that's going to be key to all of these, is knowing the parent function when we're graphing these. So on the parent function, we're always going to use the cycle of 0, pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so that cycle goes for sine, it goes from 0 to 1 to 0, -1, and then back to 0. And so we can go ahead and graph that. Let's see, 0, pi over 2, pi, 3 pi over 2, pi. All right, 2 pi. All right, so here we go. So we're going to start at 0, 0. Then we're going to go up to 1. And we're going to go back down to 0. And then now we dip down to -1 and then back to 0. So there is our parent function for sine, which we've seen a couple times already. And so now we're going to see what happens if we throw a 1/2 in there. Okay. Well, what's going to happen is if you plug in pi over 2, it really is going to be evaluating sine at pi over 4. And pi over 4 on the unit circle would actually be right here, right? And so the whole idea is we want to get it at points that are really nice, 0, 1, 0, -1, back to 0. We don't want to get these decimals here, okay? So basically, let's go ahead and figure out what the period is. So the period is 2 pi divided by that coefficient, which is 1/2. And so that should end up giving us 4 pi. Okay, so when you divide by 1/2, it's the same thing as keep, change, flip, and multiply, so we get 4 pi. So that's our period right there. Okay, so this cycle that we're about to do is actually going to take it's going to take twice as long to complete the full cycle. So we need to extend this table out. So I do want to keep going by the same increments by 1/2 a pi each time. So this should take us to 5 pi over 2, and that'll take us to 3 pi. All right, and then let's see, this next one would give us 7 pi over 2, and then this last one should take us all the way to 4 pi. So it's going to take twice as long to complete our cycle on this one. And so when you're building your table, I gave a little tip up here, and so we'll look at that as we do this. And so for right now, once again, like I said, these things will get a little bit more complicated as we move forward. But right now, we're always going to start at 0, okay? And so the cycle, we know it's going to end at 4 pi, so we know that that's our last point down here. There's 4 pi, okay? And so the tip is that basically once you know the period, you can cut it in half to find another key point. So basically you're finding the midpoint between 0 and 4 pi, which is 2 pi. And so now you've got 3 of the key points. And so now you need to figure out the halfway mark between these 2 points, which is just pi. It's pretty simple. And then the halfway point between these two, which basically I say that you can basically add the 2 halves together right here. You can add these 2 halves together, and that'll get you your next point right here. So anyways, they're all equally separated by a distance of pi. And so when you plug them in here, they are all getting cut in half before you evaluate it. So when that happens, when we do that, it's actually going to give us some nice values. So, well, 0 is not going to change anything. You're still going to get 0. Now, when you plug in pi, this really becomes half of pi. Well, you know what half of pi is going to give you for sine? It's going to give you a 1. Then when you plug in 2 pi, you're really getting pi. And you know that that's going to give you 0 and so on. When you plug in 3 pi, it's really 3 pi over 2, so you get a negative 1, and then you get a 0 here. So then let's go ahead and graph this. So we're going to go from 0, 0 to up here. We'll go up here at 1, and at 2 pi we come back down, 3 pi we dip down to here, and then 4 pi we end up over here. So this cycle, it took a longer, our cycle, our period is 4 pi, so it took a longer time to complete the cycle, basically, or a further distance on the x-axis. All right, so let's see what else we got here. Let's see, let's go ahead and try the cosine one. All right, so once again, we can go ahead and list the table values for the parent function. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so cosine as you go around, oh dear, okay, let's see. This keeps giving me problems. I might have to pause this and try to fix it, but let's see. All right, so at 0, you're going to get 1. We go to 0, negative 1, back to 0, and then back to 1. All right, so once again, we should probably go ahead and graph it. So let's see, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay. All right, so we'll go ahead and graph this one. So should be pretty familiar with this. So at 0, we'll start up here at 1, go down here, come down, we go back up. Just like that. Okay, so that's that. So now let's see what happens if we put a 2 right there. So we've got a 2 right there. So our period is 2 pi, and then we divide it by the coefficient. So this time it's only going to take 3.14 to run a full cycle. So to run a full cycle, we're actually going to finish our cycle right here at pi. So it's going to take half as long. And so once again, when we build our table, we know we're going to start at 0. We know we're going to end at pi. And so now if we want to find the other 3 key points, well, we'll cut pi in half. So that'll give us pi over 2. And then what's half of that? Well, that'd be pi over 4. Okay. And then if you want to figure out another point, if you notice, it keeps going up by pi over 2. So if you add up, 1/4 of a pi. So if you add 1/4 of a pi here, this should end up getting you to 3 pi over 4 right there. Okay, and basically you could have added those 2 halves together that we came up with in the previous step. So our key points, let's see, so when you plug in 0, you get 1. When you plug in pi over 4, what happens is it really turns into pi over 2, so you're going to get a 0 here. And then when you plug in pi over 2, it really becomes pi, so you get a negative 1 when you evaluate it, and so on and so on. Let's go ahead and graph this. So let's see, we're going to start up here. So then Pi over 4 is going to be right there. So we'll come through right there. And then pi over 2, we can see where that is right there. And then 3/4 pi is going to be right there. So we're going to come back up and hit right there. And then we're going to finish off at pi right here. And so there we go. Okay, so there's one more example, but obviously you can tell this is getting a little glitchy. So I'll go ahead and stop, and you can just look at the notes that I posted online because it is worked out. Example C, it is a little bit more challenging because you're dealing with a 1/3 in front. It's not really that bad, but anyways, go ahead and try it, and then just look at the notes online to see if you're doing it right.